off. So let's see, we got 1 lecture through, 2 lectures through, 1 more lecture on classes. Okay? So it looks like what I would like to do next is recreate our counter library. Remember that one? All this cool stuff. We had a init counter, reset, inc deck, get count. These are all functions. We had 1 counter in this library, right? This global variable is keeping track of its count. Let's turn this into classes so that we can make as many counter objects as we would like. And we can count on each of them separately. Right? So instead of doing it like this, maybe we will allow this to happen, right? Instead of making just a library where you get 1 counter only, let's make it a class so you can make as many counter objects as you want. And be like c.init, init, and then c.inc. So these are all methods now. Okay? And I can make a counter D, a counter E, a counter F. All of those things become possible with classes. So yeah, the member variable, every time we make a counter object, it needs its own count, right? So that's our member variable now. Instead of like this global variable, it's a member variable for us, count. What is our current count? Starts at 0, and when we inc it, it becomes 1, of course. And then we have all these operations that we can do to a counter. We can be like .init, .inc, .deck. All those kind of live with the class. That's how we were thinking about it. Okay? So, how do I want to do this? Yeah, I guess let's just make it happen. I believe that's how I want to start. So let's make this counter a class. Let's turn it into a class. I'll call it counter.cpp. Let's see, we're lecture 16. Alright, so here's what I'd like to do down here in main, for example. I'd like to make a counter C. I'd like to initialize it, c.init. I'd like to inc it a few times, c.inc. Those are operations. I have all these, right? Inc deck, get count, reset. So inc it a few times, then be like c out, c.get count. That's how we're spelling it. And then we could decrement it a couple times and then output that count. So instead of inc, it's deck. So init should put it at 0, 1, 2, 3. That should print 3. Then make 3, 2, make 3, 1, 2, 1. So this should print 1. Those are all the things that we should see. Okay, then like a reset method should be like c.reset to some fancy value, like reset it to 42 now. Put the counter at 42. Increment it 1 more time, and then it should be 43. Okay, so that's how I want to use this class that I'm about to make, this counter class. Does that make sense to us? Pretty logical, right? Init to start off at 0, inc it to increment it by 1 each time, deck to decrement the current count inside of our counter object by 1, reset to change it to some arbitrary count that the user gives, and then of course you can do stuff after that with whatever the count is now. And then output the count should be 43 there. Okay, so that, I believe, is a good start to everything. And now let's make our counter class. Right? We need all of these methods. Might as well just copy them. So class counter. So I have a few public methods. I have a private member variable. Here they all are. Okay. Init, reset, it's an int new count, inc, deck, get count, just give something back. Init is void, right? What is this problem here? Reset, also void, just does something for us. Inc void method, just increments our current count, decrement our current count, and then get count gives back our actual count, right? So that all makes sense. And then our private member variable, the one thing that belongs to every object of our class, is a count field, right? So let's make int count, and that's of course private. Beautiful. What else? So can any of these methods be const? Given what they're supposed to do, initialize supposed to set the count to 0, reset supposed to change the count, increment the count, decrement the count, give back the count. Which of those, if any, should be a const method? Which of them should not be allowed to change their member variable? Very good. Yeah, the getter should never be allowed to change the count. It's supposed to give back the current count. So that should be const. Good. Does that make sense to all of us? Like if this was accidentally setting the count to 42 or something every time it got called, that's definitely an incorrect implementation. So we want to guard against that. Just not even let it happen accidentally. Okay, by making it const. So, yeah, this is the count inside of our counter. I believe that's a good start. So let's go and implement all these methods now. So when we make a counter object, we can run all these on it. And we've made one down here called C. So these are the wrong names when I go and implement them outside, right? It looks like a function if I implement it like this. It's like I ask about count, like I set count to 0, like what is count? Is what the compiler says. This is just a normal function as far as it's concerned. So I have to say this is the implementation of the counter class's init method, and so you have to spell out the name in full. This is counters init, right? Counter : init. That makes it clear to C++ that, oh, this is a method implementation. Sure, yeah, you can talk about your member variable. Counters reset, counters inc, counters dec, counters get count. Okay? The reset method, you call reset on some counter. It's just going to reset the count member variable, to be whatever you asked it to be there, the new count. Inc, increment our current count by 1. Count plus plus. Same with dec, in the opposite direction. Excuse me, thank you. Count minus minus. And then finally, get count gives back our current count. And it actually is the one function, or the one method that returns something. So it's int get count. So return our current count inside of our counter object. All right? So in theory, these are all one-line implementations of all these methods. Quite nice. You can make as many counters as you want, as long as you initialize them first, of course. You can inc and dec them interchangeably, and they can all hold on to different counts. Very unlike this library that we made. We only had one count there, because it was a global variable for the library. We can make a counter D, a counter E, counter F. Okay? So let's compile and run this, see if it matches our expectations. Boop. So let's see. 0, 1, 2, 3, prints 3. Good. 2, 1, prints 1. Good. Resets it to 42, makes it 43. Prints 43. Perfect. Okay. So that's the use of our library, or our counter class, technically. And then here are all the implementations and the class definition. Any questions about any of that? So just more review of classes. Hopefully that's making a bit more sense in our minds. Are we okay with that? All right. So, I would like to tell you something now. Secretly, every method / member function, because that's the same name, right? Those are synonyms. Every method is really just a function to C++, okay? Classes are just a weird, cool little abstraction, but secretly, C++ is just calling functions at the end of the day when you call a method. Here's what happens. So let's say you say c.inc. Here's what happens inside of C++. All right? This is really getting translated to it's a method call, right? But it's secretly a function call. Every method is just a regular function that gets a secret 0th parameter, which is the object itself. All right? So this is getting translated into a call to counter : inc, like a function, with the object as the argument, as its first argument. If there are any more, those would be given too, but this was a 0 parameter, 0 argument method. It's really a 1 argument function. That's really what's happening. It's calling this fancy function name with the object, and that's how it knows to change C's count by 1. You don't really have to understand this very well, but this is really what's going on under the hood. Okay? And the name for this fancy secret 0th parameter that is the object that you're acting on is called this. It's like, who am I? What am I acting on? What's going on? It's called this. It's your secret 0th parameter. Okay? So, yeah, here's what happens in main. So, in main, we have our counter C. And C, we just initted it, right? It has a count of 0. And then we call inc. We say c.inc, which is really getting called. It's really the inc function getting called, counters inc, with C as the secret 0th parameter called this. Something like that, okay? And this is a way, it's like a pointer, essentially. It's a way of getting to C. Whee! So that's what's really happening. And so then when you say inside of the implementation, count plus plus, secretly what that's being translated into is something like, think of this like a reference to get to C down there. This is really being translated into this dot count plus plus, because that was secretly the parameter. C was secretly the parameter, and so that's how it knows what you're talking about. Okay. Secret 0th parameter. I'm not going to force you to memorize this or even understand it until CSCI 45, so you can just sit back and enjoy. But this is really what's happening. This is really what methods do. They're really just function calls in a special secret way with the object you're trying to act on as the 0th parameter. Okay? Are there any questions about that? It's a weird little concept. But eventually one day in a 4-year college, you might take a compiler's class, and you might figure out how to generate machine code for classes. And this is how you do it. It's just a function call. All right. If we're okay with that weird piece of knowledge, let's go on to things that I do want you to understand. All right? Let's talk about constructors. Okay? Because it's kind of ugly. Like back in, where do I want it to be? Back in the library, we had to call init counter before we messed with anything because our count was undefined, right? Count was undefined at the very start there. Same with our counter class. Where is this? When I make a counter object, the count inside of it, right, this private member variable, way up here, it's undefined. It's a question mark. I have to always remember to call init right after I make a counter, otherwise the count member variable is a question mark. It's set to random garbage. I have no guarantees over what it is. So I'm kind of forced to call init on a counter, and it's very, very likely that I will eventually forget to do that, right? What if I forget to call init on a counter to make sure that its member variables are all set to what they should be? C++ gives us a way that makes sure we never forget. If we always want to call something, if we always want to do something after an object gets made, we can use something called a constructor. Okay? It's a nice little name. A constructor is a special kind of method that gets called for you immediately after the object gets made. All right? That's pretty nice. So these are examples of 2 kinds of constructors for the counter class. But the constructor, it's a special method with the same name as the class. So here's a constructor for a counter. just has the same name. It's called counter. No return value either. Just called counter, parenthesis, parenthesis. Here's another constructor. This one takes parameters. Okay. So yeah, the name of this constructor, the name of the method is always the name of your class. So for counter, the constructor's name is also counter. There is no return type for a constructor, because it's kind of like obviously void. It's obviously just changing your current object, right? It's getting called for you. There's no way to hook into it and get something back. So it's kind of just, all right, I'm making a counter. We're fine. So there's no return type for the constructor, which is weird to think about, but you'll get used to it. And then what else? Yeah, you can have as many counter methods as you want. You can have as many constructors as you want, as long as they're different. Like this one takes no parameters, this one takes 2 parameters. As long as you have some differentiation going on there, you can have as many constructors as you want, optionally taking some number of parameters. Okay? A constructor that takes no parameters is this one. No parameters at all. That's called a default constructor. That's the one that's going to get called automatically if you don't give anything else. Okay? This is called a default constructor, this one. So let's make a default constructor for our counters, and also a 1-parameter constructor to like set the counter's count to some starting value at the very beginning. Okay? So let me show you all of that. So I would like to make a constructor. I'd like to make 2 constructors for my counter class. So the name of the constructor, just the name of the class. So it's counter, and the default constructor has no arguments. That's it right there. Counter, parenthesis, parenthesis, semicolon. Constructor. I'm about to make a second one as well, so I'll say S. Constructors. But yeah, this is the default constructor. And whenever this gets called, I'll implement it down here before anything else. Well, it's the same. It's counter, colon, colon, counter, but there is no return type. What do I want to have happen when the constructor runs? Well, I'd like to set the count to 0. That's how I can get away with never having to use init anymore. Okay? That's the idea. So I can get rid of init now. No longer necessary. No longer necessary. Because I've added a constructor. Okay, so its name is counter. This is its implementation. We can like print out, hey, I'm in the constructor. I don't know. Cout, I'm in the default constructor. Yay. How does it get called if it's getting called automatically? You might ask. Like it's called for you whenever you make an object. What does that mean? Here is the idea. So if I just say this line now, again, this is no longer necessary. Unnecessary. When we use constructors, just by making the object counter C, I didn't give any parameters or anything. So this line is calling the default constructor implicitly. This line calls the default constructor for us. Just do it as you were before. This makes an object. I didn't give any parameters anyhow in any method. So it's just going to call the default one. I gave nothing, so it took nothing, and it called the default constructor on counters, which sets the count to 0 and also prints out, hey, I'm inside of the constructor. So that line secretly is calling the default constructor. I'm in the default constructor. Cool, everything got set to 0, so everything still works. So this line calls the default constructor, which sets the count to 0. Are there any questions about that? It's a method that gets run the second the object gets born. And that's what constructors do. So let's use a different kind of constructor now. Let's make a parameterized constructor. One that builds a counter for us with some kind of like starting count, let's say. So this will be a parameterized parameterized constructor. And this one needs like a starting count. Okay, that's a parameterized constructor. And it will work like this. Int starting count, so it's a different kind of constructor. We can say, hey, I'm in the parameterized constructor. Cool. And the count doesn't start at 0, it'll start at whatever the user gave us. So when the object begins its life, we'll call this instead of the default one if we give a parameter. So let me show you how to do that. If you just say this, counter C semicolon on a line by itself, that calls the default constructor. How do you give non-default things? Here's what you do. You say counter D, and you don't say D semicolon, because that would call the default constructor again. You give parameters right after the name of the counter. Here's how you call the parameterized constructor. Set it, please, to 33. This calls the parameterized constructor. Okay? That's going to set the starting count to 33, just like we implemented. D.inc. And so this should print now. D.getCount. That should print 34. Yay! So I'm in the parameterized constructor, and it prints 34 after that, because it correctly got this, made the counter object in memory, jumped up here to the parameterized constructor because we gave it a parameter, yelled that it was in the parameterized constructor, and also set the starting count, or set the count of that counter D to whatever this starting count that we passed in was, which was 33. Okay? And then we incremented it one more time to make it 34. So that is constructors. Are there any questions about that? It's a method that is really, really good to initialize stuff in. It's always going to get called for you. So you can make sure in your constructor that all of your member variables are going to get values that make sense. They won't be undefined. That's where you put stuff. Are we okay with that? So those are our constructors for counters. You use them like this. Parameterized constructor call, default constructor call. Super nice. So no need for init ever again. That's quite beautiful. Okay. So we can actually do better. We can make our constructors look a bit fancier with something called an initializer list. So let me show you that. Initializer lists are the only way to call a constructor on a member variable, first of all. They're also the only way to initialize a member variable that is a const, because the second the object gets made, like, it's set, and you can't change it anymore. It's a constant. So let me show you that. You have to use this thing called an initializer list, and there's a lot going on there. So, gosh, how do I want to start explaining this? I guess first of all, let me make it clear that you can call constructors. You can have classes with classes inside of them, right? I can make a private member variable called count. I can also make a private member variable that's a vector. This vector is a class, right? Include vector. There's no reason to want to do this for a counter, but just an example. I can make, inside of my counter objects, I can always have a vector, okay? And vectors, when you build them, they have constructors, right? This is the default constructor for vectors. It's going to make it empty. This is the fill constructor for vectors. If you call it like this, I can't do it here, but it would make a vector of size 100 with 42 elements, right? How do you call a constructor on an object that's living inside of your other object, of your class's object, of a counter? And also, if I have a const here, const double D, how do I give this a value? D equals 3.14 or something. It's a constant. It should never be allowed to change. So that is where things start looking a bit weird. Like the constant, for example, you cannot set in the constructor. It's too late. You'll get a compiler error. Cannot assign to a const. you have to put it in this place called the initializer list. Same with v. You can't be like v142. It's too late. V has already been default constructed. How do we call the constructor on the vector to do what we want? You have to use this thing called an initializer list. All right? So what you do is you have your constructor, which potentially takes arguments. You put a colon. You put a colon right after that, and then you start giving constructor calls for all of your member variables, or x1 is a member variable, x2 is a member variable, all that stuff, before the implementation, before the curly braces. This is very technical, but this is what it looks like. You essentially make a little sad face here, and that's how you remember. That's where the initializer list begins. Okay? You start giving constructor calls. These are your member variables. x1 is a member variable, x2 is a member variable, and they can all take arguments to their constructors because you didn't want to use the default ones, right? So look for the sad face, and this will make more sense with an example. That's how you create an initializer list. And you can initialize anything with this constructor style syntax. Int x equals 42 could just as easily have been, C++ allows you to do it like this. Pretend that int is a class and construct it. You could say int x parenthesis 42 closing parenthesis. Those are the same line in C++. It doesn't care. This looks like a constructor call. So you can construct anything, you can build anything, you can set anything in an initializer list, even if they're just primitive types like ints. Okay? So yeah, it'll make a lot more sense with an example, I promise. So let me, I'll keep these for a second. I'll show you how. But you put a colon after your closing parenthesis for your arguments in your constructor, and then you start giving constructor calls for your member variables to build them. So for example, instead of count equals 0, I can put this in the initializer list. Oops. I can say count. Oh gosh. Sorry. Instead of this, I can say count 0. That will set the count in the same way. Constructor call. I can also make a vector. I can set v. I can call the constructor on the v vector with make 142s, please. I can set the constant d to be something now, to be 3.14, and it'll all work. This is the only place I can do these two things. I could have said count equals 0, so that's technically nothing new. But if I want to call a constructor on one of my member variables, this is where you do it, in this thing called the initializer list. Okay? And then you can use those things. Any questions about that? So yeah, let's get rid of these member variables. Now you know about them. But this is how you can set your member variables in initializer list. Okay? Say colon and then set your count, which is the one member variable again, to whatever it needs to be. Instead of this, count equals starting count, initializer list, colon, set the count member variable to whatever starting count is. And then the body, if you didn't have this printing, it could have been empty. It could have been an empty constructor body. Okay? The trick is, if I skip a member variable in the initializer list, then it gets default constructed. So if I had this v, for example, and I didn't say comma v of 42 or something, I didn't say this. By the time the object gets made, v is just empty. It was the default constructor being called on v. And that might be a lot right now, but just remember the syntax for now then. It's the colon between the closing brace, or the closing parenthesis and the opening brace. Then you give a bunch of constructor calls. You can also initialize ints like this with a constructor call. Okay? Those are initializer lists. And everything is still going to work. It'll all be the same. That's just another way to set our member variables. But I have to teach it to you because that's the only way to do certain things. That's the only way to set certain member variables. Okay? So everything is still the same. But those are maybe the fancy, most correct implementations of these constructors. Are there any questions about that? I realize that's a lot to see it at once. Definitely something to study, though. Right? So those are initializer lists. And now, let's see here. I think I have a question for you. So with this in mind, this is how you do it. Class name, colon, class name, the colon and some constructor calls. Here's my question for you. So here's the practice, my hint. Using initializer lists, try to create a constructor for points. Remember those? So that you can do it like this. You can make a point and set the x and the y field all at once to 3.5 and 4.7. But set them using initializer lists. So it needs to look like this, right? Class, point, all this stuff. We had public. Then you need a point constructor, so fill that in. Put the constructor there. Blah, blah, blah. Then you have private. Double. You have the x and the y fields down here, of course. So declare the constructor for points that takes two parameters, a parameterized constructor for x and y, and sets x and y, and then implement it. Implement it over here or something. Implement that constructor to actually use initializer lists to set the x and y fields of a point object. Are there any questions about the question? So I'm asking you to make a constructor and implement it at the same time so that you can do this kind of thing with your points. All right? So that's something to think about. Try and write down as much as you can in 3 minutes. And ask me if you're having trouble. So that is our goal. So give that a try. The name of the constructor will be point. That's for sure. Not counter this time, because that's not the name of the class. What's the other one? Okay. Okay. Take another minute to try. right. So compare what you got to what I'm about to write. So it's a constructor, right? The whole point is so that I can write this line and make the object P that has X and Y already set to 3.5 and 4.7. That's the beauty of a constructor, right? The second I make the object, I'm immediately initializing everything to something nice. And so this would be a parameterized constructor because I have to give things. Maybe the default constructor on points, if I just gave a semicolon with like set X and Y to 0 or something nice. But the name is going to be point, right? Because that's the same name of the class. It'll be point. And then you can take two things, right? They got to be doubles as well because you want to set them into X and Y. So you have to take the two things here, double, I'll call it X val and Y val. Double X val, double Y val. Y val. It's a little close. So that would be the declaration of the constructor. Does that make sense? It's got to be the same name, and it's got to take two things, one for the X, one for the Y. You okay with that? Maybe the implementation is the hard part. So you can technically name these X and Y, and there won't be any clashing in the initializer list because it's always the case that the first thing in every initializer list before you give parentheses, that must be the name of a member variable, not of a parameter. So that will come up maybe later. But here's how you implement it. You say point, colon, colon, point, double X val, double Y val, and then you give an initializer list, right? We're going to say colon now, colon, and I'm going to set X and Y, which are my member variables, using constructor calls. That's the syntax. Using like this. I say the name of the variable I want to set, and then I give in between parentheses the value that I want to set it to. X, X val. Then a comma to separate things. Y, Y val. Okay? So that's the initializer list part. And then you're always supposed to give an implementation. You give the body of your constructor. But there's actually nothing else for this constructor to do. It was just supposed to set X and Y to whatever we passed along. We did that in the initializer list. So you can have an empty body to your constructor. And it would look like that. That would be the correct implementation. Did we get that? Does that make any sense at all? It's a lot of new stuff at once, I know. But now that you've seen it, the more I do it, it'll make more sense. Any questions about this? Is this too weird? Does it make not enough sense before I move on? All right, please yell at me if you have any questions about it. But that is constructors and how to use initializer lists inside of constructors. Okay? Now I have things that are not about constructors, so you can maybe relax a little bit more. So the next thing I want to talk about are namespaces. We know that word, using namespace standard. Let me show you where that all comes from. So first of all, every class gets its own namespace, right? Remember before when I didn't say using namespace standard, I had to say standard colon colon cout, standard colon colon endl. That looks awfully similar to counter colon colon counter, counter colon colon reset. There's something going on there with things called namespaces, okay? So first of all, that colon colon, it's called the scope resolution operator. That's the fancy term for it. I just want you to think of it as apostrophe S. It's standard cout. It's counter's inc method, okay? But every class gets its own thing called a namespace so that you can do this, so that you can make two methods with the same name and they won't end up clashing with one another, okay? Namespaces are for when you want to have two things with the same name and you don't want them to clash. So I can make a counter class, a counter type, right? I drew types as clouds before, so let's do that again. So a counter type can have, like I have an inc method inside of that, and a count member variable inside of that. That's the counter class. I can come along and make a counter2 class with a different name, right? So counter2. That can be its own type. And because of the power of namespaces, because it gets a separate namespace, I can also make an inc method in that counter. And it won't be ambiguous. It'll be belonging to counter2, right? Because it'll be colon, colon. I can give that a count field. And it will not at all clash with this one from the original counter class. That's what namespaces give you, right? So let me give you an example of all this. And that should help make sense. So now you'll see exactly what the standard library is doing. Namespaces.cpp. So, yeah, the idea of namespaces, you get them for free when you make classes. They're just implicitly given to you. But I can make explicitly a namespace so that I can have 2 functions called blah and 2 global variables called x. Of course, you can't do that right now without this fancy new thing called a namespace, right? So here is int blah, which returns 42. And here's a global variable called x, which holds 55. And here are 2 more declarations of those things. So here's a blah function that returns, I don't know, 13. And here is a global variable called x that is set to 88. So these clash with each other, right? They're in the same scope. I can't compile this right now. G++, namespaces.cpp. I can't, it won't work. It's like redefinition. Redefinition of int blah, can't have 2. Redefinition of int x, can't have 2. Okay? Unless you use namespaces, unless you section these things off. Okay? So let me show you that. Let's make a namespace for these ones and another namespace for these ones. Here's how you make an explicit new namespace. You just say namespace and then you give a name. Like this is N1. This is a namespace called N1. And here are the things that live inside of it. And then here's a namespace called N2. And here are all the things that live inside of it. And now suddenly, there's no issue. This is the blah for N1. This is the blah for N2. They're separate places. So it's going to compile. I haven't actually used them yet. But now the question is, how do you pick out the one you want? Well, you just use this colon colon. Use the scope resolution operator. Or you can say using namespace N1, using namespace N2. That would also work. But here's how you use them. Let me keep the definition up here. Let's see if I can split screen it for you. So yeah, there's namespace N1, namespace N2. And then down here in main, I can use them. I can say cout, let's call N1's blah function. You just say N1 colon colon blah. Let's see out N1's x. I can do it just like that. Okay? Same for N2. If I want to use N2 stuff, I just say N2 colon colon blah. N2 colon colon x. They belong. That's where they live. They live in this namespace. Okay? So it'll do exactly what you think it'll do. Yay. I get all the outputs that I should. Are there any questions about that? That's how you make just a nice little sectioned off place where you can have the same named thing multiple times. As long as you put them in different namespaces, it's not a problem. We're good with that. So everything in the standard library, for example, if you go and look up the implementation, you can because it's open source. Every single file in the standard library says namespace standard, parenthesis, parenthesis, and then it defines all its stuff. That's what it does. That's how you build a namespace and put stuff inside of it. There's no secret there. I hope that makes enough sense. And then here's us using things from each namespace. There's just a way of sectioning off pieces in your program so that you can have 2 things, 2 functions called blah, 2 global variables called x. And so you're getting a lot of this stuff for free when you use classes. That's what I'm trying to say. So you can really, what classes are doing, they're making their own namespace for you. They're giving you a fancy way to call a function, right? So you can make your own versions of classes. You can roll your own classes by making your own namespace for everything and just putting a struct inside of it, because a struct is just what you need to hold on to a bunch of fields, right? Then you can put functions inside of those namespaces, okay? So all a class is some combination of a namespace, a struct, and a bunch of functions, just arranged in a fancy way by the compiler for you. There's no magic. But it sure looks nice when we use it. It all comes together. Are we good with that? This is kind of philosophical. This is a more philosophical lecture, I would say. So hopefully that's all right. Because the last thing I want to tell you is a really cool feature of classes, which does not exist in Java. Java sucks because it doesn't have this thing called operator overloading. This is going to make things so much easier for us. So yeah, let me show it to you. Wouldn't it be cool if I could make the plus operator work on my counter? Or instead of saying c.inc, what if I was able to say C++, and that would like increment the counter for me? It would call inc for me. Wouldn't that be amazing? C++ lets that happen. So if you have this, if you say C1 plus C2 in C++, doesn't matter if they're classes or whatever, it's going to translate this expression secretly into either this method call, C1 dot operator plus, that's the name of a method, C2, it'll look for that one, or it'll look for a function called operator plus, and it'll call it with both C1 and C2. So it's either going to translate this into this method call or this function call. It'll just find whichever one exists. You just only need to implement one of them. So if you want C++ to be able to add counters together using the plus operator, for example, all you have to do is implement operator plus. Implement it as a method or as a function. That's pretty neat. So let me show you how to do that down in our counter program. So let's assume that this is what it means to add counters. Like I have a counter C with a count inside of it, a counter D with a count inside of it. Maybe they're like 3 and 4. I'd like to be able to say something like this: counter sum equals C plus D, and have it make sum hold the count 7. They'll just add the counts inside of them. Wouldn't that be nice? Instead of saying like C.add D or something like that, just use the operator. Use the plus operator. We can make that happen if we implement operator plus. So let's go back to counters. This is what I'd like to do. Is that aligned? I'd like to say something like this: counter sum equals C plus D. That would be amazing. And be able to say cout sum.getCount. Because it would be a counter at that point, not just an int. Okay? That's what I like to do. Are you good with that? So that's what I would like to have happen. Right now, C++ has no clue how, because I haven't given operator plus plus. I'm going to get some horrible looking errors screaming about operator plus plus. It's like no match for operator plus with a counter and a counter. It's like I have no clue. Give me one of those. I don't have one. Okay? So all I have to do is implement that then. So let me implement it as a method. Okay? So this is going to secretly call, once you have this line, it tries to call, C++ tries to call either C.operator plus D, so it could have been a method inside of the counter class, or it tries to call operator plus with C and D, so it could have also been just a function. Let's implement it as a method. Okay? I think that's what I want to do. Yeah, that'll work. So I'm just going to implement a method with a very weird name. It's to be called operator plus. It'll take somebody else, and it'll add myself, right? Because I'm always there's always a concept of my current object, that'll be the C, to somebody else, to D. And then I'll build a new counter with the summed count. So let's try that. go back up here. Let's put my operators where they need to be. So I need to make an operator plus method. It's going to take somebody else to add myself to. So it's going to be a counter, I don't know, other. And we're not changing that counter, so let's take it by constant reference. You know that. And when we add one counter to another, when we add ourselves to some other counter, we have to give back a new counter, right? Because that's what this line is asking for. Counter sum equals C plus D. We're trying to get a new counter out of the deal. So this needs to return a new counter. Okay? So that's my, I guess let's declare it and implement it outside as usual. There. Let's go down here and put it above main. Counter colon operator plus. And so it's just got to build up a new counter, right? It's got to say something like counter results. Let's set results count to our current count plus the others count. That's all we have to do to build this up. 3 plus 4, our current count plus the others count. Set that count to 7 and return that counter that we built up. Does that make sense? That's kind of weird, but pretty nice. It's just a method with a very odd name, operator plus. That's what C++ is going to look for when we say C plus D. It'll try to call C.operator plus with D. And I'll get this back. And it'll work, and it'll compile, and it will output, oops, did I forget to output something? Oh darn, it's saying 77, oh, it's saying 77 because C and D have weird values, sorry. They have, it's 43 and 34 for us. So yeah, that's 77, not 7. That confused me for a second. So yeah, it's just adding them together. C++ is calling C.operator plus with D, because that's the one we implemented. Isn't that fun? We can make our own operators work for our classes. It's not just for ints, not just for doubles anymore. Any questions about that? That's quite neat. It's called that, and it's implemented like that. C++ just goes and looks for a method with that fancy name. Okay? If we're still okay, I have one last page on operators. So let's next implement plus plus. So I can say this. So I can do something like, I don't know, sum plus plus. For reasons, I'm going to implement the prefix plus plus, so it'll be plus plus sum, and we'll have this call sum.operator plus plus. That's what we have to implement, right? Operator plus plus, if I want to use the plus plus operator on my counter. And then the count should have changed from 77 to 78, right? So let's go and implement that one. That's going to be counter operator plus plus, and it takes nothing. That's the new operator. And let's implement it down here below this one. It's counter colon colon operator plus plus. And I should do the same thing as inc, count plus plus. Isn't that fun? Oh, and sorry, it's void. Excuse me, it's a void method. It just needs to change the value, just like inc. It doesn't give back anything new. So that's operator plus plus. We're calling it down here, saying plus plus sum. It's jumping up here and doing exactly the same thing as inc did. Making it 78. So you can overload any operator in C++ and have it work for your own class. There are so many. For example, you can overload these less than operators like you have for CI. You can overload what it means to be less than. You can overload the plus equals operator. You can overload the and the or operations. You could overload equality. That's the copy assignment. We already did that. Oh, sorry. We did that in CSCI 41. Excuse me. I'm getting too excited. We already did that in CSCI 41. So if you are in the future, You would have done it by now. You can overload equality, what it means for two objects of your class to be equal. You can overload all these comparisons, all these other things. Really whatever you want. It's really cool. Okay, so yeah, you can do, what does it mean to multiply two counters? What does it mean for one counter to be less than another counter? How do I print a counter to see out? Kind of like that. Plus plus, we did that one. How fun is that? Okay, so let me implement operator less than for you. That will be my last trick, because that will allow us to sort a vector of counters, because that's how it compares things. C++, if you call sort on something, it just needs to know when one thing comes before another. And so it's going to look for operator less than on whatever you're trying to compare and therefore sort. Okay? So here's a silly thing that you can do. I can make a vector of counters, V, and I'll put, I don't know, sum in it, and C in it, and D in it, and C holds 34, I think, or no, D holds 34. C holds 43, D holds 34, and sum holds 77, so it's like in reverse order right now. I can sort my vector V. I can say sort v.begin, v.end. And it's going to go looking for a less than comparison operator on counters. Let's say that one counter is less than another one when the count inside of that counter is less than the other's count. Okay? So this is going to go looking when I say this sort call. Sort will call operator less than on my counters, 2 at a time. So it'll go looking for, hey, is C.operator less than on D a method that I can look at? It'll also try for this one. Is there an operator less than function that I can call with C and D? Let's do it the function way this time. Let's implement that one, and it'll find it, and then I could see out my sorted vector V of counters. So for counter, counter in V, see out that counter's count. New line. Okay? And then, let's do space. And then new line at the very end. So this sort call is going to go looking for less than operator. And we're going to give it this one on counters. And if I want sort, I need to include algorithm, because that's where that one lives. And so here it is. It's just a function. I'm going to make a function that takes two counters and returns whether or not one's less than the other. So bool operator less than on two counters. So counter A, counter B, and we might as well take them by constant reference. Const counter reference B. And I think that'll do it. So this is a function. It can only call methods. I can't be like, hey, return whether A's count is less than B's count. I can't access private member variables outside of the class. This is just a function. And so I have to do something like this. I have to say return whether or not A's get count, that's still going to give me the count, is less than B's get count. That's what it means for a counter, a whole counter, to be before another one, to be less than another one. It's when their counts are less than. Okay, when A's count is less than B's count. That's when A comes before B. Okay, and so it'll return true or false, depending. And that's all the sort function needs to know how to sort something in ascending order. So it'll change this vector from sum C and D to be, I guess it's going to be D, C, and then sum in that order. That's the smallest one, is D, I think. So I get this vector at the very end. It's 34, 43, 78. It's sorted by increasing count, because that's what I told C++. That's what it means for one counter to be less than another one, when their counts are less than. And so then it sorts it in ascending order, and everything is beautiful. Okay? So that called this operator less than function. Are there any questions about that? We covered a lot of ground today, and this is definitely one of those lectures to go back and study. There was a lot of information, but let's cover where we were, what we did. It's mostly this counter class, right? So, class counter. I can have constructors. Let's split screen this. I can have constructors which get called automatically for me when an object begins its life. You can say counter C semicolon. That calls the default constructor. I can say counter C or counter D with 33. That calls the parameterized constructor to do whatever code needs to be done there. For us, that involves setting the count. Okay, setting the count using an initializer list. These only exist for constructors, by the way. You can't have an initializer list in your reset method, for example. That doesn't make any sense. Only for constructors. And then we had our normal methods. One was const. We remembered that. And we also learned about operators. What does it mean to add a counter to another one? Operator plus. What does it mean to say plus plus on a counter? Operator plus plus. All these things down here. What does it mean for one counter to come before another one? That was operator less than. So if you want to implement an operator, you just say operator, and then the name of it comes right after. That's the name of the method / function that you go and implement. So you can think of this as just like .add, .inc, .am I less than somebody else. They're just weird names, but those allow you to use these kinds of operators on your classes, which is lovely. Makes it easier to think about them, in my opinion. Okay, so that is pretty much everything that we covered today. That was the end of classes. That was everything that I wanted to teach you about object-oriented programming, for now at least. Are we good with that? Any questions about all this fancy stuff that we've been learning? Maybe our brains are a bit fried after this one, and I respect that. So yeah, that was all I want to say about classes. Yeah, we don't even have a new lab this week, it seems. So yeah, everything that you know about is already out. That's all I have to say.